Dear 10th standard students, in this video we are going to see the continuation of Unit 5 previous class portion. Let's move on to the topic. Velocity of sound waves. What is velocity? Velocity is the rate of change of displacement. When you talk about the velocity associated with any wave, there are two velocities. They are particle velocity and wave velocity. What are they? Particle velocity and wave velocity. The SI unit of velocity is meter. What is called particle velocity? Particle velocity is the velocity of a particle in a medium as it transmits a wave. It is the velocity of a particle in a medium as it transmits the wave. The SI unit of particle velocity is the meter per second. Example, when applied to a sound wave through a medium of a fluid like air, particle velocity would be the physical speed of a parcel of fluid as it moves back and forth in the direction of the sound wave. Dear students, don't confuse the particle velocity with the speed of the wave. That is, in the case of a sound wave, particle velocity is not the same as the speed of sound. The wave moves relatively fast while the particles oscillate around their original position with a relatively small particle velocity. From the above explanation, let us see what is called particle velocity. The velocity with which the particles of the medium vibrate in order to transfer the energy in the form of a wave is called particle velocity. What is called particle velocity? The velocity with which the particles of the medium, the particles alone vibrate in order to transfer the energy in the form of a wave is called particle velocity. What is called wave velocity? The velocity with which the wave travels through the medium is called wave velocity. The wave travels through the medium. In particle velocity, particle alone travels in the medium. In wave velocity, the wave travels in a medium is called wave velocity. We can define the wave velocity also like this. That is, the distance travelled by a sound wave in unit time is called a velocity of a sound wave. That is, the velocity is equal to distance by time taken. What is called wave velocity? The velocity with which the wave travels through the medium is called wave velocity. There is a relation between velocity, wavelength and time. The distance travelled by one wave is taken as one wavelength lambda. The time taken for this propagation is one time period capital T. Then we can write the expression for velocity v is equal to lambda by t. The distance travelled by one wave is one wavelength and then the time taken for this propagation is t. So, the velocity v is equal to lambda by t. From this equation, the velocity can be defined as the distance travelled per second by a sound wave. The velocity can be defined as the distance travelled per second by a sound wave. That is distance by time. Since frequency n is equal to 1 by t. That is, in the equation v is equal to lambda by t. In that we know that frequency n is equal to 1 by t. So, in equation v is equal to lambda by t, we substitute the value of t. In n is equal to 1 by t, we have to find out the t value. So, t is equal to 1 by n. Now, substitute this value in the equation v is equal to lambda by t. Then that equation becomes v is equal to lambda by 1 by n. Now, the n goes to the numerator. Then the equation can be written as v is equal to n lambda. So, in the equation v is equal to lambda by t, we substitute the value for n 1 by t. From this we have to find out the value for t. T is equal to 1 by n. So v is equal to lambda by t becomes v is equal to lambda by 1 by n. Now the n goes to the numerator, then the velocity v is equal to n lambda. This equation is very important. What is the relation between velocity, frequency and wavelength? V is equal to n lambda. Among the three medium where the velocity of a sound wave is maximum, it is maximum in solid. What is the reason? Solids are more elastic in nature comparing to the liquids and gases. Gases are least elastic in nature. So the velocity of sound is least in a gaseous medium. So we can write the equation as Vs is greater than Vl, Vl is greater than Vg. That is, the velocity of sound is greater than the velocity of liquid. Velocity of liquid is greater than velocity of gas. So where the velocity is maximum? In solid. Where the velocity of sound is least? In gas. Now we are going to see what are the factors affecting velocity of sound. When we take the solid medium, the elastic property and the density of the solid affect the velocity of sound waves. In case of solids, the factors that affect velocity of sound waves are elastic property and density. How can we characterize elastic property of solid? We can characterize the elastic property of solid by their elastic modulus. What is elastic modulus? It is a measure of an object's or substance resistances to being deformed elastically when stress is applied. When we apply the stress to an object, it deformed. It is called elastic modulus. It is the measure of an object resistance to being deformed. Object resistance to being deformed elastically when stress is applied is called elastic modulus. The speed of sound is directly proportional to the square root of the elastic modulus and inversely proportional to the square root of the density. That is, the factor affecting the solid is elastic modulus and then density. Now what is the relationship between the elastic modulus and density to the solid is? For elastic modulus it is directly proportional and then for density it is inversely proportional. So the velocity of solid in solid decreases as the density increases, whereas the velocity of sound increases when the elasticity of the material increases. Directly proportional means when the elastic modulus increases, so velocity of sound also increases. When the density increases, velocity of sound decreases. It is inversely proportional. So in solid, the factors that affect the velocity of sound wave are elastic property and the density of the solid. Now let us see the factors that affect the velocity of sound wave in case of gases. In the case of gases, the following factors affect the velocity of sound waves: effect of density, effect of temperature and effect of relative humidity. In a gas, the velocity of sound is inversely proportional to the square root of the density of the gas. The velocity of sound in a gas is inversely proportional to the square root of the density of the gas. See the equation, V is proportional to square root of 1 by D. That is inversely proportional. What are the term inversely proportional? Velocity and density. If the velocity decreases, the density increases. If the velocity increases, the density decreases. So the velocity and density both are inversely proportional in effect of density in case of a gaseous medium. Effect of temperature. Here the velocity of sound is directly proportional to the square root of its temperature. The velocity of sound in a gas is directly proportional to the square root of its temperature. If the velocity increases, the temperature also increases. That is, V is proportional to square root of T. Don't forget the square root. V is proportional to square root of T. When the velocity increases, the temperature also increases. So, the velocity at temperature T is given by the following equation. Vt, that is with the velocity at temperature, is equal to Vo plus 0.61 temperature ms minus 1. Here what is Vo? Vo is the velocity of sound in gas at 0 degrees Celsius. For air, the velocity is 331 ms minus 1. When the temperature changes, the velocity of sound also changes. That is, when the temperature changes by 1 degree Celsius, the velocity of sound changes by 0.61 ms minus 1. In this above equation, V is proportional to square root of T. The velocity at temperature is given as Vt is equal to Vo plus 0.61 T. When the velocity changes, the temperature also changes. That is, when the temperature changes for 1 degree Celsius, what happens to the sound? The velocity of sound also changes by 0.61 ms minus 1. Effect of relative humidity. When humidity increases, the speed of sound increases. During rainy season, if your friends speak to you from long distance, you can hear the sound. The reason is, during the rainy season, when the humidity increases, the speed of sound also increases. Hence, we can hear the sound from long distances clearly during rainy season. It is very important. So, when humidity increases, the speed of sound also increases. That is why you can hear sound from long distances clearly during rainy seasons. Now, let us see the speed of sound changes in different medium. We can consider the medium solid, liquid and gas. In this tabular column, we can see the speed of sound in different medium. Let us take the three medium: solid, liquid and gas. In solid, we take the medium as copper, iron and aluminium. So, the speed of sound in copper is 5010 ms minus 1. The speed of sound in iron is 5950 ms minus 1. The speed of sound in aluminium is 6420 ms minus 1. Now, let us take the liquid medium. In liquid medium, the speed of sound in kerosene is 1324 ms minus 1. The speed of sound in water is 1493 ms minus 1. The speed of sound in sea water is 1533 ms minus 1. In gaseous medium, the air at 0 degrees Celsius is 331 ms minus 1. In the air at 20 degrees Celsius is 343 ms minus 1. It is very important. One word question. They will ask in one word question. Choose Phillips. Okay. Thorough the tabular column. What is the speed of sound in copper? The speed of sound in copper is 5010 ms minus 1. So, study all these values. Thank you, students.